Welcome back. This is an additional lesson I've added to week 3. This lesson will take you step by step through the code that you need to write to solve the fox and hen problem. So this lesson will take you through every line of code you need to write. There's 2 ways you could do this. One is to just watch it straight through and then perhaps come and watch it again and write the code as you go. Or you could open Python right now and pause my video and then go on through it, stopping it as you go and writing each line as you see it on the screen. So in any case, this lesson will help you to complete the task that I have set for you. So to remind you, the Fox and Hen game could be one stage in an adventure game that you might write. And the program we're going to write is completely text-based. But the idea is that the hero has to get across a river. And she's got to take a fox, a hen, and a sack of grain with her. She can only take them one at a time. It might be on a bridge or a boat or something. If she leaves the fox with the chicken, the fox will eat the chicken, and if you leave the chicken with the grain, she will eat that. So that's the problem. We've got to set it up so that the user can play this game. And if they give the right choices in the right order, they'll get over the river without disaster. This lesson is going to take you step by step through writing the program. There are 7 different things we've got to achieve to make the program work. We've got to use abstraction to simplify the problem down to its basic parts. We've learned last week why that's so important. We've got to design an interface. That's the user's what the user sees on the screen. It will output the information that they need and take their inputs as they play the game. We're going to put the game into some kind of a loop so that it keeps repeating. The person can keep making choices until they've either won or lost the game. Inside the game, the user is going to have to be crossing the river backwards and forwards. So we've got to make that happen in some way. The user's going to pick one of the creatures, the fox, the hen, or the corn, and cross the river backwards and forwards with one creature at a time. Every time they make a choice, we're going to have to check to see if they've won or lost the game. And finally, we'll have to finish the program with a message that tells them that they've won or lost. By breaking the program down into these 7 much simpler tasks, I increase my chances of success hugely. This is called decomposition, breaking a problem down into its parts. We'll learn more about that over the weeks to come. Well, the first thing we're going to do is think about the problem and use abstraction. What details do we need to have for this program? And what can we leave out? We can leave out almost everything, all the details of the person, the fox, and so on. It just doesn't matter. What do we absolutely need to keep? We should only have that in our program. I'm about to bring up the answer. Have a think what you would say. I think we only really need to have the names of the creatures. It doesn't really matter anything else about them. We just know that it's a fox, a hen, and some corn. As long as we've got that right, we're okay. And the only thing we need to know about all these different creatures are which side of the river they are on. That's the only fact that we really need to know about them. And the only decision I have to make is which creature I take with me as I cross the river. So really, I can boil my whole program down to just those facts. So that's how I'm going to start the game. Let's think about representing which side of the river people are on. People or foxes or whatever. The only thing that we know about the river is that it has a wrong side, that's where we are at the moment, and a right side, that's where we want to end up. And we're going to be able to cross the river to swap between the wrong side and the right side and back again. When we've got a binary choice like this, where there are only two possibilities, I immediately think of using a Boolean variable that has the values true and false. We'll call the wrong side of the river false and the right side of the river true. And that's all we really need to store about our three participants in the game, the person, the fox, the hen and the corn. Just true or false. So let's get going with our programming. This is the start of the game. I've used a couple of comments to just get things started, and then I've created 4 Boolean variables called fox, hen, corn and person, and I've set them all to false because they're on the far side of the river at the moment. They're on the wrong side of the river. And so that's what my abstraction has done. It's changed a big complicated program into a nice simple one with 4 Boolean variables. Next, we're going to create the user interface. And the user interface has to take care of input and output. Let's think about output first. What does the user need to know? The user needs to know where each of the 4 things are. Are they on the right side of the river or the wrong side of the river? And then I just need them to make one choice to choose which thing they're going to take over the river with them. Here's an interface that does all of that. It shows you the 4 components, the 4 parts of the game, and next to each one it says whether they're on the right side of the river yet or not. Of course, we know that at the start of the game they're all on the wrong side of the river. And there's an input statement that asks which of the 3 they want to take with them, the fox, the hen or the corn. So let's go through the code to make that happen. Remember that in our output we want to show where each thing is. So my first part of my output is just 3 print lines. I'm printing, have they crossed the river? I've done a big underline, and then I'm printing out the information about the fox. I've got the word fox, and then I've got the variable fox. Remember, that's a Boolean variable that just says true or false. You might be tempted to just write the word false, but that won't work. You need to use the variable because it's going to change as the game progresses. So the word fox and the variable fox. So if you haven't done it yet, pause the video and write these lines of Python. Now, can you extend your Python to show the same information for the other 3 members of the game? There's that code. So you should have caught up with all of this by now. If you haven't, pause the video. You can always rewind and write the whole program so far. Now we're going to write the input line. We have to choose which of the 3 things we're going to take across the river with us, the fox, the hen or the corn. And we've got to store the input using a suitable variable. You might be able to write this line without seeing what I'm doing, so pause the video. Here's my answer. I've called my variable move, but you can call it anything you like. I've used an input command and I've written a prompt for the user. And just to make it easy for them, they don't even have to write the whole word fox, hen or corn, just the initial letter. This command goes at the bottom of the outputs. So all the output lines that I've already written and the input line. In fact, I'm adding another line as well. There it is. I'm writing a long, just a line across the screen to make it look a bit neater. So that's my interface, actually. I've done it. And if you've written the same code as me, when you run your program, you should see something like this. So let's stop now, catch up with the first two parts of the program, setting the initial values and displaying the interface. Run your program and make sure you see something very much like what's on the screen right now. And when you've caught up with all of that, go on to the next screen. So going back to our list of step-by-step tasks, we've done the first two already. We've created the abstraction and we've designed the interface. Now we're going to put the whole thing inside a loop. A lot of games go inside a loop so that you can keep making the moves in the game. So I'm going to show you the code for that right now. Here's the code we've got so far. If you haven't done all of this, this is a good time to catch up. We've set the starting values and we've got the interface. Which part of this is going to go inside the loop? This part is not going to go inside the loop. These are the starting values for my program. If I put this inside the loop, my program would go wrong because I'd be putting the fox, the hen, the corn and the person back on the wrong side of the river every single time. So clearly those lines do not go inside the loop. But these lines do go inside the loop. These are the lines that display the output and ask for input. And that's something we want to happen over and over again while our program is running. So I'm going to put those lines inside a while loop. I'm going to use a while loop rather than a for loop because I don't want it to repeat a certain number of times. I just want it to keep going until the game is over. I've used while true and I've indented all the lines that I want to go inside my while loop. While true, of course, is always true, and that means my loop will keep going forever. That's not really a final answer to how to make this game go, but it's what I'm going to use for now until I finish my program. So that's what your program should look like if you've kept up with all the code. So we're working our way quite rapidly through the tasks that we've got to do. We've used abstraction to simplify the problem, we've designed the interface, and we've put the interface inside a loop so that it keeps repeating. Now I'm going to write code so that every turn the person crosses the river, regardless of what they take with them. We'll do that bit later. So we're just going to make the user cross backwards and forwards across the river. So remember, in this program, the user, the player, is going to keep crossing the river. I identify the two sides of the river as the wrong side and the right side, or to put it another way, the Boolean values false and true. And each turn, the user is going to cross the river. The person swaps sides every turn. They swap and then they swap back. and then they swap back again. So the user is going to go backwards and forwards, true, false, false, true. They're going to keep swapping backwards and forwards from side to side of the river. What Boolean operator can we use that turns true to false and false to true? If you know how to do this, have a go at writing the next line of the program for yourself. But if you're not sure, don't worry, it's going to come up on the next slide. Here's the code that you need. I've added one extra line to the program. This line will swap the person from one side of the river to the other. It's inside the while loop, so it will repeat every single turn. Remember, person is a Boolean variable that stores the values true or false. Not is a Boolean operator. It turns true into false and false into true. So it will just swap backwards and forwards between true and false every time. This is a good time to write this code and then run the program. And as you run it, you will see that you swap from true to false and false to true every time you press a key. So try that now. Have you got your program working? Remember, you can always rewind and rewatch any part of this video that you want. We've now actually done most of the tasks in our game. The user is crossing the river each time. Now the only things that we've got to add are commands to bring one of the creatures with her, to check for win and lose, and to write a final message in the program. Let's start by moving the fox only. This is definitely the best way to approach a problem. Try and solve one small part of the problem first. Get that working and then extend it to other variations. When do we take the fox with us? When we type the letter F, then we take the fox with us. But there's another thing that has to be true as well. You have to be on the same side of the river as the fox. That means you and the fox, person and fox, have to have the same identical Boolean value. You're either both on the wrong side of the river or both on the right side of the river. So we've got to write an if statement that has both of those tests in it. Let's try and do that now. Here's a possible solution. I've combined the two tests with an AND operator. So if the move variable has the value F and the fox and the person are on the same side of the river, then move the fox. And the move command, fox equals not fox, that's just the same as the one I used to move the person. You could do it another way as well, and I know some of you have done this. You could use nested if statements. That would also work. So choose whichever one you want. I think this is just slightly simpler, but it's up to you. Now that you've got the fox command working, and if you haven't, you should do that right now. Run it and make sure that it works. Now extend the program to add exactly the same type of commands so that you can move the hen and the corn. I'm going to show you that on the next slide, so pause the video and write that code right now. Here's the whole thing. This is the working code. You'll add all of this inside the while loop. This code will move the fox if you type F, the hen if you type H, and the corn if you type C. You might notice that I swap the person's position after I've done all of those if statements. There's a good reason for that. If I moved first, then all the if statements wouldn't work properly because they're checking if I'm on the same side of the river as the fox. So I have to do that check before I move. When you've got this working, try running the program. Your game is almost ready now. The only thing that we haven't done is check for win or lose. There we are, our checklist. You could even write a checklist like this for yourself as you write a program, or you could put all of those headings in as comments and then write code next to each comment. Anyway, it's up to you. As it is, we're right towards the end of the program now. We just have to check if we've won or lost the game. Just to remind you how to win or lose the game, we lose if we leave the fox with the hen. That means the fox and the hen are on the same side of the river and I am on the other side of the river. I'm not there to guard the hen. Look at that poor hen worrying about being eaten by the fox. Or, slightly less dramatically, if I leave the hen with the corn and I go to the other side of the river, the hen will eat the corn. So that's how I know that I've lost the game. But I've won the game if we're all on the right side of the river. So I'm going to make that happen now. Once again, I'm inviting you to have a go at this on your own. But when you're ready, let's see how I've solved this problem. Well, I've got to set win and lose to false at the start of the program, because at the start of the program, I haven't won or lost. So go right back up to your starting values and add two new ones called win and lose. I'm doing this whole game really with just Boolean variables, almost all Boolean variables. So can you write this code without seeing it? The right code's going to come up in a second. If the fox, the hen, and the corn are all on the right side of the river, then you've won. Remember, what counts as being on the right side of the river is being true, having the Boolean value true. So let's see what that looks like. If fox and hen and corn, basically if those values are all true, then win is true. It can be as simple as this because fox, hen and corn are Boolean variables, and so I can just use them instead of logical tests. So if fox and hen and corn are all true, then you've won. Win is true. Make sure you've put this into your code. Now let's make a similar if statement to check for losing the game. The first lose condition is that the fox is with the hen. So the fox and the hen are on the same side of the river, but on a different side of the river from you. So that's two tests and they both have to be true. So can you write that code? I'm going to show you in a minute. So pause the video and write your code. Here it is. If the fox and hen are the same, but the fox and the person are different, then lose is true. You've lost the game. Do you remember the second condition? We can do that as a separate if statement. That is if the hen and the corn are in the same place, but the hen is in a different place from the person. Can you write that code now? Very similar to what you see on the screen. And there it is. If the hen is with the corn but not with the person, then you've lost the game. Right, we're nearly there now. We're right towards the end of our list of tasks. Now I'm just going to finish the program. What I'm going to do is change the while loop so that the game stops when I either win or lose, and then there's just a message at the bottom to tell me if I've won. So I'm going to loop until win is true or lose is true. And I'm going to show a message after the end of the loop that tells me if I've won or lost. Just from that information, can you write the final bit of code? I'm going to give you opportunity now, but don't worry, the right answer's on the next screen. So my while loop did say while true, and that meant it just looped and looped forever and ever. But what I want it to do is loop when I haven't won and I haven't lost either. So as long as win is not true and lose is not true, I want to keep playing the game. So go up to where it says while true and change it so it looks like this. And then finally, below the loop, tell me if I've won or not. You don't have to use those messages. I've used if else, because if you've won, you should see a message. Otherwise, if the loop has stopped and you haven't won, I'm afraid that means you've lost. So here's a message to tell you that. We've done it. We've got a working program that solves the Fox and Hen game. If you're my student, I'd like to see that. I'd like to see that program. You can document it or just show me the program. You could run some tests and show me the tests. All this would be great to see. So your work is to complete the program. You can improve it as well if you've got time. So at the moment, there aren't many messages to the user, but for example, we could be saying to them, you took the fox with you, or you chose F, but you're on the different side of the river from the fox, so nothing happened. Or whatever it is, or you could say, the fox ate the hen, to tell them why they've lost the game. So we could add some extra messages in the right places to make the game experience more fun. And I've also set this challenge for some of my faster programmers to create a visual appearance like this, so that it actually shows which creatures are on which side of the river, and the river is shown as a kind of line across the screen. This is much more difficult doing that, so only do that if you really want an extra challenge. If you decide to do some extra fancy stuff like this, why not save your original program so that you've definitely got something to upload for me to see, even if you get a bit stuck with some of the later tasks. All right, so well done for sticking with it. I hope this has really helped you to do your work. This is one of the longest lessons I've ever uploaded to YouTube, and I hope it's helpful to you. I'll see you next week. Bye for now.